Annyeonghaseyo. Thank you and welcome to Eskwelabs Data Science Manila Cohort 5 Demo Day, Innovating for the Recovery. I am Caleb Tutty, the CTO of Eskwelabs.
And annyeonghaseyo to you, Caleb. I'm Angela Chen, the CEO of Eskwelabs, and it's great to see you all here virtually. So Eskwelabs is an online data upskilling school based in the Philippines, and our mission is to drive social mobility in the future of work through data skills education, so more people can thrive in the future of technology, data, and machines. So in other words, we turn you, whatever your current state is, into future Nando-san. So you might be wondering, ano ba yan? What are these references? So this demo day event is uniquely inspired by the Netflix show Startup that has taken Asia by storm. It's currently the top show in multiple countries in the region, and let us know in the comments if you are also watching it right now. So we love this show for a few reasons. So first, of course, is getting people excited about technologies in novel ways, like its colleague explanation of machine learning using Jane and Tarzan. It's also using relatable stories to really tell us about the ethics of AI and the real impact of automations on lives when jobs are lost. Finally, and this is my personal reason for standing the show, it highlights the unique opportunities of young people today who can take on risks and build something wonderful, not just for profit, but for their community. And this applies not only for startup founders, but also for anyone who wants to create a meaningful career, just like the Eskwelabs Fellows.
That's right. The show Startup sets the perfect context for you to meet our data science fellows today, who are also using machine learning techniques to uncover opportunities for innovation in the post-COVID world. Although we are not able to gather in person like we used to for past events, we hope their passion will equally resonate with you. They will also be joined by an additional company. We have invited data scientists from the field, Lorenzo Ampel from Thinking Machines and JC Peralta from Ayala's AC Energy Philippines, who will provide live feedback for their projects. Lucille Schnitzer from Omdena will share more about how you can join AI projects for good on a global scale. And finally, we invited a very special musical guest, Mikey Misalucha, who will be wishing those of us who are BTS fans happy holidays. Mikey is performing for the benefit of typhoon relief efforts for Waves for Water and the Computer Professionals Union.
Thank you, Caleb. So let us share with you what's changed for Eskwelabs and the Data Science Fellowship since COVID. So in this cohort, we launched project-based learning using tech sprints to better adapt to now the fully online learning experience. So our fellows still attend class live with the support of instructors, mentors, and work together to produce projects like e-commerce segmentation for customers, credit detection, a music recommender system for Spotify, and a Telegram chatbot.
And they are still doing that with a community that's built around supporting their career growth. We are super excited to roll out these unique styles of skills education to more learners in 2021.
So as you know, the pandemic has caused great disruption in all of our lives and our societies. It's also accelerating the flight to digital. So as we enter this unique period of opportunity to shape how the future looks like, we hope the insights from the Eskwelabs Data Science Fellows today will offer different versions of how that recovery looks like.
Some of the household names like AirBnB and Uber have one thing in common. They were founded in the aftermath of the 2008 global financial crisis. We are hoping that our fellows, armed with data skills, will take part in the rebuilding and perhaps even in creating future startups. So we won't make you wait too much longer. Let me call on our hosts, Thea and Rick, our hosts for today.
Hi, thank you for that, Caleb and Angela. Yeah, Rick, would you like to introduce what we're doing today?
So hi, my name is Rick, and with me is Thea, and we'll be your hosts for today. So today is an exciting day as you will be watching a Filipino demo day themed up with the #1 K-drama on Netflix, Startup.
And hello to our audience who are tuning in from our live on our Eskwelabs Facebook page. Later on, you guys will have the opportunity to interact with the people behind the projects through the comment section below.
So Samsung Tech and Injay Company won't pitch today, but rather you will hear 6 amazing projects of our fellows with ideas to make an impact on our society. So information about the projects can be found on the data science page of our website at bit.ly/data science capstone gallery. So that would be bit.ly/data science capstone gallery. You can also find this link in the comment section below, so do click it and head over to our website. Stick around and listen attentively, guys, because at the end of this session, you can vote for your favorite project and explore the opportunities we have for you.
So, Rick, I know Sodalmi and One Inje won't be here, but did we invite Han Jipyong and Namdo-san as our guest judges?
Nah, we didn't invite them, but rather we invited 2 industry experts who are handsomely looking like them. Meet Lorenzo. He is a machine learning product manager and data scientist at Thinking Machines, a global AI consulting firm with operations in Singapore and Manila. He specializes in developing products that utilize deep learning and machine learning on NLP for various industries. Prior to this, he set up his own consulting practice where he provided end-to-end data science solutions for finance and tech companies in Southeast Asia and Australia. He also previously worked at Uber as an analyst, where he handled projects related to NLP, analytics, and automation for the APAC region's community operations.
And meet our second judge, JC. As a data scientist, he believes we are called to play an important role in nation building, to identify, measure, and propose corrections to society's inefficiencies to make it a little bit more livable for everyone. He keeps this principle in mind and heart at his current work as a data scientist in the analytics arm of Ayala Corporation Energy Philippines. He trained for 6 years as a climate researcher specializing in regional monsoon dynamics and climate model evaluation.
So both of them would ask questions after every presentation, and after that, we will open the questions to our audience. So again, for everyone watching, feel free to drop your questions in the Facebook comments below. So now let's get started. But wait, before that, Thea, guess what? It's exactly 27 days until Christmas. Have you planned out what gifts you'll be giving to your friends, family, colleagues, and to me?
Not yet, Rick. I'm so sorry. I got so busy working from home recently and I didn't have any time to check. I guess I need to go out and see the latest trend for gift giving.
Well, Thea, there's no need to do that. You can shop online, and I've heard that there's this website that recommends gift ideas perfect for the Christmas rush. So our Santas, Emmer, Dan, Rob, and Ran, will share with us how this is used. Let's go watch.
Good afternoon, everyone. I am Dan, and joining me are my good friends Emeran and Rob, and we are presenting Santa All Grant to Wish this holiday season, where we try to build an e-commerce gift recommender system based on user-generated wish lists. The pandemic has usually affected our lives, and that includes our usual Christmas gathering. Moreover, gift giving became a lot harder because we are all stuck at home. And so we thought of a specific solution for this very specific problem. Through e-commerce marketplace, the project aims to facilitate gift giving by providing users an easier way of finding appropriate gifts for their friends and their loved ones. Because in the end, we might not be together physically, but we can still be closer together through our minds and our good intentions. So to provide us further background about the project, here is Emmer.
So before we discuss this feature, we first want to emphasize the potential of the e-commerce industry, at least in Southeast Asia. The potential for e-commerce in C is big. So this is no secret. This is a very well-known fact. E-commerce GMV in Southeast Asia grew by 63% from 2019 to 2020, and it's expected to grow to 172 billion US dollars by 2025. And it's also growing very fast. Over a third of 2020's online commerce was generated by new shoppers. And these new buyers are also sticky, of which 8 in 10 intend to continue buying online going forward. So this is why e-commerce marketplaces are scrambling to get an early slice of this huge potential. And since holiday shopping and gift giving is already inherent in Filipinos, having this feature that supports that will give an e-commerce player an advantage over competitors. It will allow them to attract shoppers to go to their platform due to the ease and convenience instead of the competitors. Okay, so for our feature, wedding registry-like wish lists. So users will be given an option to create multiple wish lists which they can choose to make public, like a wedding registry. After adding products to their wish list and making it public, they can share it with their friends, and then their friends will now know what their friend wants and choose a gift to purchase for them. After purchasing, the e-commerce site will now deliver the product to the buyer's doorstep. So it's that easy, and it adds a social aspect to online shopping. Okay. So this is where data science comes in. So the wishlist feature will be accompanied by a recommender engine that will help users build their wish list. So as you can see here, this is what the UI is going to look like. The user has the option to make their wish list public or private using this toggle. And this is where the products are going to appear. And this is where the recommender system is going to recommend products. This is where the user can add the recommended products directly to their wish list. And now we will be discussing our methodology.
Thanks, Emmer. So now, we proceed in discussing the methodology for Santaol. We mainly use Python as our main programming language, together with these technologies to make Santaol. You may check our Heroku app online to see our full documentation. Now, we look at the dataset that we used for our project. We scraped our data from Shopee, one of the leading e-commerce platforms in the Philippines. Afterwards, we did some data wrangling, where we removed duplicates and null values, among others. After some feature engineering, we arrived at a dataset having 41,943 unique products and 21 different main categories. In this slide, you can see how our script automatically gets data from Shopee. It actually took us almost 2 weeks with our computers open day and night to scrape all of our data. To build a recommender engine, we mainly use the product name in 3 levels of categories: main, subcategory 1, and subcategory 2. We also filtered our results by rating, number of items sold, interest, discount rate, and trusted seller. Now, to discuss the pipeline, here's Ran.
Thanks, Rob. Now let me share you how we arrive with the recommender engine. First, we normalize each product name to have consistency. Next, by using PFIDF, we get the importance of each word to its respective categories. We then use network theory to correlate products and categories, and this results in getting the most relevant categories. To get the most relevant products, we use KNN, and lastly, to filter the most performing products, we created a scoring system, and now we got the recommended products.
So this is now where it gets exciting. We deployed the recommender engine in Django to show you how we envision the application. Also, earlier today, we thought of doing a Secret Santa ourselves, and so we already prepared our own wish lists.
Oh no, I forgot to create mine. But just give me a second and I'll try to create mine.
It's okay, Ran, no problem. Let me and Rob guide you. So on the homepage, you can see some of the gift ideas based on some filters like categories and price range. So you don't have to do it manually.
But first, let's try to create your wish list. For starters, Ran, what have you been doing lately?
Lately I gained a lot of weight. So maybe I want to do yoga again.
It actually works in 2 ways.
Same.
You can leave those wishes as it is, but if you want to make them more specific, you can click the magnifying glass to look at the recommendations.
Oh, I want a yoga mat and I also want a resistance bands.
Amazing. Now you can share it to your community, where you have the option to make it public or private. Now, let's look at the next feature, the community feature. Let's look at Emmer's wish list.
Oh, I didn't know Emmer is a gamer. And you, Rob, likes gardening.
Yes, he's a certified plantito now, actually.
Wow. And now let's see Dan's wish list.
Yeah, go ahead, look at it.
Oh, it's random.
Oh, sorry, I forgot to tell you, but you could also do that if you want surprises like me. Isn't it amazing? Now we can easily facilitate gift giving. You know what, guys? I really hope our projects can reach and help a lot of people.
Yes, I like it very much. It is easy to follow and it is more convenient.
That's
Now,
That's what we offer to our users actually. Ease of use and convenience. Now let's look at the documentation.
So, if you are curious on how we conceptualize the recommender engine, you may visit our Heroku app online with the link to be shared with you later on. Earlier, we have already discussed the sections from introduction to feature engineering, so we are skipping that. So for now, we will show you some of our exploratory data analysis. But feel free to check them out using the link for the interest of time. We also deployed a working recommender engine. Let's try searching for a gaming mouse and look at its results. But as a disclaimer, when you try out a recommender engine, you may encounter errors when trying to search for very specific products, but nonetheless, it should work as fine in general. Here, you can see the top results of the gaming mouse. You can also see the top rated products and the most popular ones among others. We now discuss our evaluation and recommendations.
Okay, so we didn't get a chance to deploy our model in an actual marketplace, but we thought about how we would evaluate it if we had the chance. Click-through rate would be looked at to measure the relevance of content being served by the recommender system. So if our system, for example, recommends 3 products and the user adds one of those to their wish list, then we would have a click-through rate for precision of 33.3%, meaning 33.3% of served products are relevant to customers. We would also want the feature to increase the average revenue per user of the platform, which we expect it to do. And our goal is for our feature to convince customers and friends to buy their gifts from our platform instead of a competitor's, whether that be offline or online. And lastly, we want our feature to invite buyers to our platform due to the social aspect of it, as well as increase the overall revenue of the platform. As for our recommendations, we would attempt a hybrid filtering approach for our recommender engine. Currently, we're using a content-based filtering approach. We thought about this because we want our model to recommend more complementary items to items in the wish list rather than substitute items to better increase average order value. But we would need transactions and user data to do this. We thought about implementing this as a third-party website also, which would then aggregate products from all the platforms, which would make money through affiliate commissions. Lastly, another project idea, analyze product reviews to get ideas for product improvement and a better understanding of consumer feedback. Since reviews on platforms, at least here in the Philippines, are mostly skewed to the positive side. Okay, so you guys might be wondering, why Santa All? As you might have guessed, Santa All is a spin on the popular Filipino phrase, Sana All, which means hopefully everyone, rough translation. With our new feature, everyone can be Santa this holiday season and grant their friends holiday wish. So remember your loved ones and send them that gift they always wanted. Thank you.
Thank you very much for that presentation. Take it away, Lorenzo and JC, if you guys have any questions.
Hi. Well, first of all, like really well done. Like it's really impressive stuff. Like, I was honestly, I'm guessing it's gonna be like this for the rest of the talks, but I came in kind of expecting like focus on EDAs and standard stuff, but it looks like you're pitching a full-fledged like feature and even like a product that you can actually roll out. So that's really great. One question I have is, it's great that you have an app ready and you had some propositions on how you could measure performance. So my question is like, how would you implement the retraining pipeline once you are measuring, let's say, click-through rates?
So, well, at first we would not have an idea of what a good click-through rate is. So we would first let it run and then first get the initial numbers for click-through rate. And when we observed that, for example, the average order value didn't increase as expected or didn't do a lot better or significantly better than the way it used to, for example, compared to a static page, then that's when we would think about tweaking it more. And then, of course, we would be looking at click-through rates, and then if the average order value increased significantly. So I guess that's when we are going to insert the retraining process in the evaluation phase.
But when you say retraining process, you mean that you are going to be using the click-through rates as sort of like label data in some way?
Well,
or is it more of like it's like a notification? It's like a monitoring tool, which will then indicate to you that, oh, hey, I should like retrain the pipeline when CTR is like lower than what it should be.
Yeah. Something closer to the last thing you mentioned.
Okay, cool. Thanks.
Hi everyone. Okay. So Dan, Emmer, Rob, and Ran, good job on the presentation. I really like your deployment product. It's very well made and it's almost as good as if it's a real e-commerce site feature, no? So I have two questions. How fast is a typical query, and would that benchmark of time elapsed after a query vary for a specific category of the products?
So currently, a typical query lasts for about 2 seconds to 5 seconds, but it depends on the internet of the user and also the bulk of the app, the Heroku app deployed online. So what we thought about was trying to deploy our data sets or using our data and deploy it on some kind of like a cloud, like in MongoDB, to facilitate a faster return of products in queries.
Okay, sorry. But I could assume that there would be some skewness in your training data set as regards to the categories of the products that are present. What were there dominant categories in your training data set, and did that introduce a bias to the recommender engine that you built?
Actually, that's a problem we've encountered while we're training the model. At first, when we are scraping data, we were gathering from all the categories, but later on, we saw that it can affect our model. And so what we did is we tried to balance the data set for each category. So yes, that's what we currently do.
Yeah, and to add to that, in an actual e-commerce marketplace, actually, the categories aren't really balanced. So there would be categories with more products in reality. So it's going to probably recommend more of this category simply because there are more products in that category. So, but for our project, yes, we try to balance everything out.
Okay, maybe just one more question. So I'm concerned about the ethics of the recommenders engine that you built. Well, it applies for all recommender engines, no? So this would appear as in the back end as a series of clicks on the items, but actually these series of clicks would reveal an individual's behavior, a real person's behavior. So say if this recommender engine, a public wish list, was used by, say, a lady who wants to shop for her an upcoming newborn, but she's not yet ready to announce it to her family, with just a simple search, that wish list would be accessed by anyone, and that information that she's not yet ready to share would be, of course, known by those people. So as developers of this kind of AI product, what are the features that you plan to add to the platform to ensure the users' data privacy?
Okay, so for the question about the sharing the public wish list and the security of that, well, we thought that the making a wish list public is going to be a choice made by the user. So by default, wish lists are going to be private, and then the users can choose to make it public. And when they do, they will be given a disclaimer on what's going to be the consequences of what they're doing. And then the shareable link, of course, it's up to them who they share it with, or to the community that they have if the platform has a friend or community feature. And when it comes to, for example, delivery, the address won't be given to the friends when they share the wish list. So it would be kept on the e-commerce platform side. So yeah, those were the features that we thought of to kind of mitigate a bit of the security issues here with this feature here.
And to add to
Good.
that, we also would want to share to our users how we process their data. Of course, we would promise transparency on what we are going to do with their data, especially the personal and possibly sensitive ones that can be used in bad light. So yeah, that's what we're gonna do. We're gonna promise transparency to the users.
Good job, everyone.
Thank you very much, Team Santa All, for that presentation.
You know, Rick, that gift recommendation system was actually really cool. I wish I knew how to make something similar to that, like making their whole app. I mean, yeah, whole app from scratch.
Well, that's just one of the many cool things that a data scientist can do, Thea. So anyways, data science, after all, has been called the sexiest job of the 21st century. Right now, data skills are sought after by many companies.
That's very true. I see so many job openings related to data. And if you're wondering what companies are actually looking for in a data scientist, don't worry because we've got you covered because our fellows, Nox, Gab, and Jelly, will share with us the state of the job market for data roles. For all the aspiring data scientists watching us today, listen closely because this one's for you. Let's all welcome them to the stage.
Hello, good afternoon. Most of the attendees here would like to know how to pursue a career in data science like me. I'm Janina, and here with me are my groupmates, Nox and Gab, to present our capstone about comparing the state of the data job market across Southeast Asia. This topic is very close to my heart as I would like to know my place in the data-related ecosystem. As a job seeker like me, I would like to know where can I find these jobs? Are these jobs available in my location? Who is hiring? Because business acumen is important in becoming a data scientist. Building a career for a thriving industry would be helpful. And lastly, what skills and technologies needed to get a data-related job? So why is this study relevant? While this is not from our research, we want to showcase the growing prospect of these different data roles in the region. LinkedIn 2020 data shows how many of these data roles we examine are included in the top 10 jobs per country. As the amount of data grows in the world and its use cases grows, we expect that the number of data-related job opportunities to grow as well. We hope our project demonstrates the nuances in what local job markets are looking for and how a job seeker can better prepare for these opportunities. Of course, as work becomes more remote and job places become borderless, the global demand for data roles also matters. We conducted our study by scraping the most commonly used job sites in the Philippines, Indonesia, Singapore, such as Indeed, JobStreet, Caliber, and Glassdoor, by entering the following keywords: data scientist, data engineer, business intelligence, and data analyst. Details such as the name of the company, industry, job posting date, and description were extracted. We focus on the jobs that are hiring locally, thus excluding those that hire remote jobs permanently to obtain the job density based on location. After removing duplicate records, we obtain a total of 4,699 job postings. To conduct the study, first we scrape the data from the job sites using Selenium. To process the skills and qualifications needed, we use Lucano to annotate and define custom entities. Data cleaning is then performed using regex, and once the data is clean, we are able to perform data analysis to obtain insights and recommendations. We will provide more detail as we move on to our discussion.
To start off with our exploratory data analysis, here we will focus on one of our research questions: where are these data jobs located and what are the common hotspots? In this slide, we begin with the heat map of our country, Philippines, and we color-coded the provinces to clearly see which areas had more job positions available. The darker the shade means that it had more job posts. Clearly visualized on the map, The small portion that is Metro Manila has the darkest shade and it represents more than 1,000 data-related job posts. To scale, the capital of the Philippines has more job posts than the total of job posts outside of Metro Manila. This may be the case as business-centric locations and big companies are in the capital, which then are key seekers of data scientists and analysts. Let's see on the next country, Indonesia, what are the hotspots are for data-related jobs. So in this heat map, we see Indonesia having the same pattern of hotspot as that of the Philippines. The region with the most number of data job posts are in Jakarta, which is the capital of Indonesia. It is worth noting that Jakarta has a total of 1,062 job posts, while the rest of the regions in Indonesia has less than 100 data-related job posts. This continues the pattern of having the volume of data jobs in the capital, where bigger companies may be found. With regards to Singapore, we do not anymore do a heat map since the country itself has a smaller land area than that of Philippines and Indonesia. Although we still were able to identify that central Singapore had most of the job postings and leads by a wide margin, further supporting the claim that most of data-related jobs are at the capital or center of countries. Now that we've located where most of these data jobs are found, let's analyze the type of industry that most of these jobs are classified to. And to talk about that more, let me call on Janina.
Let's get to know the industries that are hiring. This is based on a list taken from the Global Industry Classification Standard. Next. To observe the prevailing industries per country, let's take a look at the spider chart. The longer the spoke is, the higher the contribution of the industry. Both Singapore and Indonesia have the same top three industries, such as IT and services, professional services, and banking and finance. This makes sense since Singapore is the main headquarters of some IT companies. Moreover, it is considered as a global financial hub. Philippines has a different set of top three with professional services at the top since it is well known as a BPO hub.
Now, moving on to our third research question, what do companies look for in skills? To answer this question, we first had to figure out a way to extract the relevant information from all the lengthy unstructured job descriptions. We created a custom-named entity recognition model using Docano. We chose 6 custom entities to train our data with. First, we have the specific skill tag, which includes specific tools and technologies such as SQL, Python, and R. Next, we wanted to obtain the more general kind of skills such as machine learning, natural language processing, statistics, and so on. We also decided to create the years of experience, education level, degree, and salary as label tags. We then annotated 300 job descriptions with these custom labels, and we were eventually able to apply our model towards our entire dataset of 4,699 job descriptions to extract the most important information efficiently. Now, let's take a look at what each country prioritizes in terms of tools and technologies. Here are the top 10 most mentioned keywords for tools and technologies. Labels with colored highlights mean that the keyword is found in all 3 countries. Here we observe that SQL and Python are consistently within the top 3 for all 3 countries. Other common tools mentioned are Excel, R, and Tableau. But which tools really set the countries apart? The tools which are enclosed by a cyan or a light blue circle denote skills which were uniquely included in that country's top 10 list, meaning it did not show up in the other 2's most mentioned keywords. Factoring these unique skills in, we can see that companies in the Philippines prioritize Microsoft products such as Excel, Office, and prefers Power BI over Tableau for its data visualization. Singapore, meanwhile, prefers tools related to big data, as seen in their preference for Spark, Hadoop, and Hive. Indonesia, on the other hand, ranks Java and Linux highly, which implies its focus on software and data engineering-related competencies. Now, looking at general skills, we notice that there is a similar trend for the top 5 list of each country. Machine learning tops the list for everyone, while skills such as big data, data analysis, data mining, data visualization, and business intelligence can also be observed. As to what unique keywords can be found for each country, the Philippines looks at statistical analysis and data collection, while Singapore focuses on deep learning and AI, while Indonesia emphasizes programming language and software development, which essentially matches the specific tools and technologies they were looking for shown earlier. Now, if we look at years of experience desired by employers, Singapore notably seeks candidates around the 3 to 5 year range, while companies in the Philippines have a lower requirement, around 1 to 3 years. Indonesia, on the other hand, has a more balanced approach for this category. For education level, we immediately see that the Philippines and Indonesia have a similar view, focusing more on bachelor degree graduates, whereas Singapore places a much higher importance on master's and PhD graduates. As to what specific degrees companies seek in a data role applicant, we see that all countries look for the same set of degrees with just a few minor changes in the ordering. These are computer science, engineering, information technology, statistics, and mathematics. Now, while all of the job roles in our study deal with data, the responsibilities of each are not exactly the same. For instance, a data analyst focuses more on analyzing what has already happened, while a data scientist focuses more on predicting what could happen. So just how similar or how different exactly are the skills needed for these roles? Now, looking at the top skills mentioned for each job role, we notice that data scientists and data engineers had several overlapping skills. Machine learning and big data are the common themes for these skills. Meanwhile, data analyst and business intelligence roles were even more similar to each other, with data analysis and data visualization being the common themes. Now, Python is a very important skill to have for the first group, whereas Excel is very important for the second group. SQL remains important across all data roles. And as for unique keywords, Microsoft Azure, a cloud computing platform, is one such example for data engineer, while PowerPoint appeared prominently in the business intelligence roles.
Now let's discuss how this project helps our stakeholders. So it helps the Eskwelabs team in identifying the proper skill set for their students to equip in order to be ready for various industries. For job seekers, individuals looking to be hired in a data science position can improve their job hunting by optimizing their search with the correct keywords. And then for companies, hiring companies are able to refine their job postings on specific positions needed. Furthermore, companies may also evaluate level of competency of their own data science departments. For our limitations and recommendations, although the model gathers significant information, enhancements can be made to extract more valuable insights. Perhaps a more sophisticated model in which a job post could be classified as either a data analyst, data scientist, or business intelligence will be helpful so that job seekers may fully understand the role that is being taken, as well as companies to identify what they really want and look for rather than tagging it with a mistaken identity. Additional data across time to account for seasonality and when jobs are posted. For instance, repeating the scraping during peak hiring season like in January might yield different results from a larger sample size. And lastly, productionizing this project will be beneficial in simplifying the process of gathering data and insights. Automating the process of web scraping, model implementation, and exploratory data analysis will save time and deliver more data. So to summarize our project, Singapore sets a higher standard when looking for data scientists. While Philippines and Indonesia are at par with each other, most data science jobs are found at the capital or center of a country. Information technology and services is the leading industry looking for data-related jobs. Python and SQL are the most in-demand skills for data science positions. Thank you for watching, and we are now ready to answer your questions.
Okay, I can start. I can start my video for some reason. Am I expected to? Okay, start. Okay, cool. So good job, everyone. So I think you're actually touching on a pretty interesting topic, right? So this idea that data science was like flourishing all of a sudden, and people got into it really quickly, but a lot of people started hiring a lot of companies, and not everyone's happy because there's some sort of mismatch. So I think a lot of the general insights were actually quite intuitive, right? Like Python, R coming out, and the word frequencies. I think one thing that sort of came into my head though is if you're scraping from LinkedIn, you're probably familiar with this existing. It's a kind of like a critique and notion that HR people on LinkedIn in general are not very good at describing what they want when they're hiring for data jobs, right? So you've probably seen that meme about everyone wants a unicorn. Like they give a job description with all of these like things, and then actually what they're looking for is like an IT team or something like that. So I was wondering, did you have any steps to sort of filter through those kinds of job descriptions, right? So in other words, like, did you have some way to be able to filter or maybe even improve the quality of the job descriptions that were being posted across these 3 countries? Yeah, that's my question.
Well, actually, we know that limitation. Like, it's a reality, and for our study, we really, since we only had a few weeks to prepare, we weren't able to really do a deep drilling down of cleaning. So we focused more on really looking at the job role. So the keyword job role. So that's how we approach this project. So we really chose the 4 job roles: data scientist, data analyst, data engineer, and business intelligence. Now, that's actually something that we are aware of. And given more time, we actually would have wanted to clean up the data set more. But yeah, given the time we had, we focused more on just removing the duplicate job descriptions, and then making our study based on these 4 major job roles.
Right. So, but how would you, let's say you have 6 more weeks to do it, like, how would you perform that cleaning? Like, what would be your process, and like, what's your kind of like thought process around that?
I think for let me just add on to what Nox said. I think, yeah, even though we had more 6 weeks, I think it's part of our model that we only tag just say the years of experience and then the tools that we need. But I think generally speaking, yeah, there are some things that are intuitive, like Python or and uh, say SQL. So these are things that are really we cannot say replace or edit just to clean our data. I think it's really that if these tools are really part of the data set, then we cannot just dwell away from it. So I think we just really have to trust us really what we have in our data, and it's also part in that case we can also have insight that maybe in the Philippines we have a different definition of a data scientist, so we can clearly see a bigger separation from the data scientist definition from the Philippines and then for the Singapore. So I think that's what I think for the insights for that.
Just to add something to what Gab said. Actually, what you suggested, I think it would be better if we were to apply it on a follow-up study. I think because our initial study was really meant for exploring what skills are really commonly mentioned in these jobs. So that was our first focus. Now that we have a better understanding of what companies look for, that's when we get a better idea also of classifying and cleaning the data to really identify which entries shouldn't be part of the data set. So it's more of a follow-up study, I guess. Next steps.
Cool. Thanks, guys.
Great. Okay. Thank you, Nox, Jelly, and Gab. Thank you very much for your presentation.
Wow, Rick. So, like, after listening to the previous presentation, it seems that investing in data skills is really the way to go.
Well, here's another fun fact about data science for you. So did you know that some of the well-known data scientists in the Philippines are physics majors?
Really? I I I didn't know that physics and data science are actually related.
Well, yes, there are many interesting things about physics, and who better to tell us more than our physicist, Paul. Take it away, Paul.
Okay, good afternoon. My name is Paul, and I'll be presenting my capstone project entitled A Survey of Physics Research in the Philippines, aka Topic Modeling of Abstracts from the Sambaang Pisika ng Pilipinas SPP Congress from 2010 to 2020. As we can see here, the Philippines has one of the lowest number of researchers per million and percent GDP expenditure on research and development. So the Philippines has 186 researchers per million, and you might ask, in those 186 researchers per million, how many of those do research in physics? So as of 2003, the number of physics PhD holders in the Philippines is not more than 70. And that translates to 0.8 physics researchers per million as of 2003. As we can see here, certain developed countries such as Japan, Denmark, Sweden, and Finland, they both have high number of researchers per million and percent GDP expenditure on research and development. It is very difficult to do physics in the Philippines because of the following reasons. First, there are only a few schools, which are 5, offering PhD programs in physics. Second, the likelihood of success in pursuing a career in physics research is low, because as you can see on the right hand side in this graph, that on the average, it takes 7.9 years to earn a PhD degree in STEM. And lastly, there are only a few capable mentors, meaning there are only few people who can train the future generation of physicists. So as we know, the technologies that we enjoy today are a result of physics research. Now, for example, astronomy, unexpectedly, through technology transfer, we had innovations in communications, GPS technology was developed, and certain medical imaging devices such as MRI were developed as well. And not only does physics contribute to new technologies, physics also contribute to new methods of problem solving through the development of new maths and algorithms which are useful in fields outside of physics as well. Now, for example, calculus and Monte Carlo methods. Now, and recently, this year, we had our first gravitational physicist. Just to comment on how young we are or how far we are compared to other developed countries, gravitational physics is a field of physics that is almost 100 years old. But just recently, we just had our researcher in that particular field. So for the data set, I was able to obtain 1,981 abstracts with corresponding title, author names, author affiliation, and Congress code. I was able to obtain all of these information via web scraping. So through the years, the SPP in Congress from 2010 to 2020, as we can see, there are dips in the number of presentations. We expect as the years go by that the number of presentations will steadily increase. This is not the case, however. And it is very interesting to note that for the 5 schools that offer PhD programs in physics, UP dominates the percentage of presentations. It contributes to 70% of the presentations. I also used the word cloud of the 1,981 abstracts as a reference for my stop words list removal. So here is an overview of my modeling process flow. And these are the libraries that I used in modeling. So for the data pre-processing, it has 5 components: tokenization, lemmatization, bigrams computation, stop words removal, and bag of words. So I used 2 algorithms in topic modeling, LDA and LSA, which are the most commonly used topic modeling algorithms. So when you input a bag of words model to a topic model, it outputs different topics. So you can arbitrarily set the number of topics, and also gives as an output the topic distribution. So a topic in the context of topic modeling is just a cluster of words that occur frequently together. So for model tuning, I use the coherence score as the evaluation metric. The higher the better, it goes from 0 to 1. And I also adjusted the hyperparameters, for example, number of iterations, to get better coherence scores. So, and also to have more sensible results in the topics, I kept on updating the stop word list. And so I built different models, corresponding to different numbers of topics, and I just chose the number of topic with the highest coherence score. So in selecting the best model, so here is the comparison of LSA versus LDA. As the number of topics go greater than 6, we can see here that LDA is more accurate, meaning it has a higher coherence score in general. And as we can see, for the LDA, the coherence score peaks at k is equal to 13, or 13 topics. And LSA, although it is less accurate, it trains faster. However, LDA, although more accurate, it trains slower. So I'll choose the LDA topic with k is equal to 13. So I visualized the model using PyLDA Viz. As we can see here, the different topic numbers and the top words associated with the topics. So we can see here the different circles. No, we can see there are certain topics that overlap with each other, are very close to each other, and the size of the circles correspond to the distribution of the topics. So insights and conclusion. Though there are not as many physicists in the Philippines, they work on a variety of research areas. And these research areas are quantum physics, given by topics 1 and 2, optics and photonics, given by topics 4 and 8, condensed matter, given by topics 2, 3, 4, 11, gravitational physics, given by topic 7, plasma physics, given by topic 10, meteorology, given by topic 7, complex systems, given by topics 5, 13, and physics education, given by topic 12. So if you're an aspiring physicist, there are people who could mentor you if you're interested in solving problems related to these areas. So the Philippines needs more physicists as a developing country because physics research contributes to the development of new technologies and methods of problem solving. Although becoming a physicist in the Philippines is a very hard journey, from attending school and earning a PhD to doing actual research for a living, however, it is very rewarding, especially when you love finding things out. So as I end my presentation, let me give a quote which is very close to my heart by Richard Feynman. And thank you very much for your attention, and I'm now ready for your questions. Thank you very much.
Hi, Paul.
Yep. Hi, JC.
So good job on your presentation. The topic is also close to my heart since I'm also an undergrad. I also spent my undergrad in physics department and also my master's. No, so I'm actually a data point in your data set. I have submitted like 2 abstracts, not on the same year. I submitted 2 abstracts in SPP.
Yeah, I saw it.
Okay.
I saw one.
We're from the same family.
Yeah.
So Paul, you've successfully extracted topics for that whole bunch of words in the proceedings, no? But you also have that year in your dimension in your data. So what I was about to ask is, did you spot any trends with each of the individual topics you spotted across the years? Were there topics that are gaining more popularity, and were there others who are kind of not in a good popularity level?
No, I wasn't able to check the distribution for different years. I just used
Mm-hmm.
the number of years to show the if the number of presentations are growing or not. Like if you're having more researches. So, pero I wasn't able to
Mm-hmm.
consider the distribution for different years.
Okay, then maybe that could count as a recommendation for future work. Thanks, Paul.
Thank you, JC.
So thank you very much, Paul, for your presentation. So that's really awesome. We're just in our first half, but I learned so much. So how much more when we hear the last 3 projects?
I agree, Rick. I want to remind our audience that after everyone's presentation, they will get the chance to vote for their favorite project.
So while you guys are thinking about that, we will be having a special performance for the benefit of the communities most affected by the recent typhoon. So just a little bit about our performer. Mikey Misalucha is a Filipino singer-songwriter who made her recording debut in 2018 with her EP Highs and Lows. She is currently signed under Open Door Management, managed by Guji Lorenzana. Mikey believes that she is her own genre. that through her fashion style and music, she gets to express herself and hopes that it would inspire others to love themselves inside out.
Mikey was nominated for Wish Ballad Song of the Year in Wish 107.5 Music Awards 2018, Best R&B Recording, Best Collaboration, and Best Inspirational Recording for the Awit Awards 2019, and R&B Album of the Year and R&B Artist of the Year for the 11th PMPC Star Awards for Music in 2019. So let's all welcome Mikey Misalucha.
Yay! Thank you so much, guys, for that introduction. Can you guys hear me? I just want to know if you guys can hear me.
Yeah, we hear you loud and clear, Mikey.
Okay, cool. So thank you so much for inviting me to your demo day. And I heard that you guys have a theme, which is like the startup Korean drama theme. So I'll be singing one K-pop song and one original song. So I hope you guys, like it and loosen up a little bit from all of the discussions and the presentations that you guys been doing. And I just want to say you guys are really like amazing. Like I can't even understand some of the things you're saying, but elibs ako. Wow, ayan. So I hope you guys like this, and yeah. Shoes on, get up in the morning, cup of milk, let's rock and roll. King Kong, kick the drum, rolling on like a rolling stone. Shoes on, get up in the morning, cup of milk, let's rock and roll, yeah. King Kong, kick the drum, rolling on like a rolling stone. Sing song when I'm walking home, jump up to the top of LeBron. Ding dong, call me on my phone, I see in a game of ping pong. Huh, this is getting heavy, can you hear the bass boom? I'm ready. Life is sweet as honey, yeah, these bitches ain't like money. Disco overload, I'm into that, I'm good to go. I'm diamond, you know I glow up. Let's go, cause I'm in the stars tonight. So watch me bring the fire, set the night alight, yeah. Shining through the city with a little funk and soul. Light it up like dynamite, whoa. Bring a friend, join the crowd, whoever wanna come along. Word up, talk the talk, just move like we up the wall. Day or night, the sky's alight, so we dance to the break of dawn. Ladies and gentlemen, I get the medicine, so you should keep your eyes on the ball. Huh, this is getting heavy. Can you hear the bass boom? I'm ready. Life is sweet as, yeah, this beach chain like money. Disco overload, I'm into that. I'm good to go. I'm diamond, you know I go. Let's go, cause I'm in the stars tonight. So watch me bring the fire, set the night light, yeah. Shining through the city with a little funk and soul. Light it up like dynamite, whoa. Da na 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 na. Life is dynamite. Da na 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 na. Life is dynamite. Shining through the city with a little funk and soul. I eat up like dynamite. Oh, da na 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 eh. Da na 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 eh. Da na 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 eh. Light it up like dynamite, yeah. Da na 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 eh. Da na 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 eh. Da na 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 eh. Light it up like dynamite, 'cause I'm in the stars tonight. So watch me bring the fire, set the night alight, yeah. Shining through the city with a little funk and soul. Light it up like dynamite. 'cause I'm innocent tonight. So watch me bring the fire, set the night light, yeah. Shining through the city with a little funkin' soul. Light it up like dynamite. Whoa, na. Life is dynamite. Na. Life is dynamite. Shining through the city with a little funkin' soul. Light it up like dynamite. Oh. Yay, thank you. So I'm guessing you guys know that song. So that was Dynamite, obviously by BTS. And again, thank you guys so much for having me, and for Bella for inviting me. And for this next song, this is my last song. I hope you guys like it. This is an original song, and this is my latest single called La La La. So I hope you guys like it. It's available on Spotify, iTunes, and YouTube. So I hope you guys listen to it again if you guys like the song. So yeah, thank you guys again, and God bless you, and good luck to everybody. Mm-hmm. Swapped up when you said hi. I suddenly felt butterflies. I was captivated by your deep green eyes. Pero tingin ko kaibigan lang ang turingan hanggang doon na lang. 'Cause every time you open up your mouth, things go south. But I cannot resist the way you bite your lips. Something about you I cannot predict. That's it. Every time you la 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 makes my heart go la la la. I don't even know what you're doing, but you make me la la la. Every move I la la la. I don't even know what I'm feeling. Di alam kung ano meron ka na hinahanap-hanapin kita. Every time you hold and open up your mouth, I don't like you. You're confusing, a little loving, so conceited, but I like it. I can even hear a word you say, so stop and listen. Every time you la 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 makes my heart go la la la. I don't even know what you're doing, but you make me la la la. Every move I la la la. I don't even know what I'm feeling. Ahem. Pag tinitingnan kita, everything's so perfect. Pag ngumingiti, good looking and I think you know it. Tawa kong pilit even though I don't know what's funny. Boy, I try so hard, don't even know if you like me. Do I like you? I don't think I do. But do I mean it? Maybe a little bit. I don't want to think about what this really is. All I know is you and I'ma go into the great abyss. Makes my heart go la la la. I don't even know what you're doing, but you make me la la la. Every move I la la la. I don't even know what I'm feeling. Thank you.
Thank you very much, Mikey. I was
Thank you.
honestly really bopping to that last song.
Thank you.
I've been converted to being your fan. I'll definitely look into your Spotify and have that song on
Wow,
repeat.
thank you guys
Thank you so much for joining us, Mikey, and I hope you enjoy the rest of your evening.
Yes. Thank you guys so much. Good luck and God bless you.
Thank you, Mikey.
Thank you, Mikey.
So actually, this demo day showcases data-driven innovations in e-commerce, energy, healthcare, and more. So while data science has the potential to improve our lives in many ways, technology is an enabler and not a panacea. We are living amidst the reality of climate change, and vulnerable communities cannot wait until technological solutions are there to solve the impact of natural disasters.
To this end, the demo day will also serve as a virtual fundraising event for relief efforts, including those from the Computer Professionals Union and Waves for Water Philippines. Visit their FB pages for more details about the fundraiser. We'll also be sharing the links down below in the comment section.
So thank you for that, Rick. We greatly encourage everyone to participate in this relief effort. So now, before we move on to our next presentations, I have one question for you, Rick. 424,000. Do you know what this number represents?
No, what is it, Thea?
That is the total number of COVID cases here in the Philippines today.
Oh, well, yes, as we know, COVID has affected so many lives all over the world, which is why it is important for us to know if there are adequate health facilities in our country.
Yes, Rick, I agree very much. And in our next presentation, Ruth will be sharing with us a report on the accessibility of health centers, specifically in NCR and ARMM. Please take the stage, Ruth.
안녕하세요. I'm Ruth Cabria, and I'm here to present to you the geographical analysis of healthcare facilities in the Philippines. First, let me share with you a patient's journey. The patient was rushed to a hospital A, where they found that the patient suffered stroke and aneurysm. However, hospital A cannot perform the surgery, and they recommended hospital B. However, in hospital B, the surgery cost 500,000 pesos. The patient doesn't have that amount of money. Good thing, there is a government hospital C in Manila, 25 kilometers away, where the surgery costs 180,000 pesos. But before the surgery, the patient has to go to hospital D for a laboratory test that is unavailable in hospital C. The patient waited in the hospital's hallway, pre and post surgery, because there's no room available. That was the story of my relative last February. And so I asked, what is healthcare accessibility really? According to the World Health Organization, accessibility in healthcare is the availability of good health services within reasonable reach for those who need them. And so I categorized accessibility into three types: distance, duration, and affordability. First, let's look at the Philippine geography. The Philippines is grouped into 3 islands: Luzon, Visayas, and Mindanao. Sorry. Sorry for that. So the Philippines is grouped into 3 island groups: Luzon, Visayas, and Mindanao. It has 17 regions, 81 provinces, 7,641 islands, and 42,000 barangays. And on the graph on the right, you will see the rural distribution by population of each region. So you can see that the Philippines is a heavily rural country. So the top 5 rural regions are Region 8, Region 2, Region 1, Region 5, and the ARMM. So where are the healthcare facilities? According to the National Health Facility Registry, there are 30,637 registered facilities, of which 23,000 are barangay health stations, 2,500 are rural health units, 2,100 are birthing homes, and 1,380 are hospitals. So the question now is, do we have enough hospitals? 1,380 hospitals for 109 million Filipinos. That gives us 79,000 Filipinos sharing one hospital. But according to DOH Administrative Order 2006-0004, the recommended bed to population ratio is 1 to 1,000. So hospital levels are based on the DOH guidelines, level 1, 2, and 3. For level 1, there are no ICU. Level 1 hospitals should be able to provide minor care and supervision and minimum healthcare services. For level 2, it has ICU and with specialist doctors. And for level 3, it has additional training program for doctors, rehabilitation facilities, and dialysis units. So here are the hospitals in the Philippines. 67% are private. 45% of the hospitals are in Luzon, particularly in NCR, Region 3, and Region 4A. And 48% of Level 3 hospitals are in NCR. 3 out of the 17 regions do not have the Level 3 hospitals. So, comparing urban versus rural, I selected one highly urban region, which is NCR, and 3 rural regions from Luzon, Visayas, and Mindanao. So as you can see, for NCR, there are 197 hospitals, 146 of which is private. And for ARMM, there are 30 hospitals, 22 of which are government. So we can see that the distribution of hospital per population is really huge. For NCR, 65,500 share the hospital, but for ARMM, 127,000 people share one hospital. So comparing urban and rural in accessibility in terms of distance and duration. So what I did is to generate the lat long of the hospitals using Google Maps Places API, get the nearest hospital per barangay centroid, generate the distance and duration using Google Maps Distance Matrix API. So as you can see in NCR, the median distance of one barangay to a hospital is 1.1 kilometers with a median duration of 5 minutes. And the maximum hospital distance of a barangay to a hospital is 8 kilometers. Whereas for Region 2, the maximum is 301 kilometers and the median duration is 7 hours. As well as for Region 8 and ARMM, the median distance is 14.8 kilometers and 10.4, and the median duration is 25.26 minutes, with a maximum duration of 3 hours and 27 minutes, and 3 hours and 24 minutes. So public healthcare is really under-resourced and thus often of poor quality. Despite having the universal healthcare, we cannot guarantee the quality service for all Filipinos given the huge disparity between urban versus rural communities. So the question now is, should we add more hospitals? Maybe not now, due to the following reasons. First is the shortage of medical professionals. Clearly, we do not have enough medical professionals to man the hospitals. Next is the existing hospitals do not have enough supplies and equipment to provide quality health service. And addition of private hospitals may not improve the situation, especially in rural areas due to cost. Lastly, insufficient DOH budget from the government to sustain the existing healthcare needs of the population. So what can the government do? I highly suggest that every region has level 3 hospital to train our future doctors, and for DOH medical scholarship to include more scholars coming from rural regions. Lastly, for the government to ensure each hospital can produce quality service by providing sufficient medical supplies and equipment. And what can we do as a community? I really believe that we have a moral obligation to be the voice of those silenced by poverty. So let us continue to seek accountability from the government regarding the healthcare system in the Philippines. If the government can spend on Dolomite, they can spend on saving people's lives. Thank you.
Feel free to ask your questions already.
Okay.
Hello.
Okay. JC, you can go.
Sure. Okay. So Ruth, thank you for your presentation. Very impactful intro, and I like your strong messaging. So I think your main data science output is the routing of using GMAP's API from barangay to the hospitals, right?
Yes.
So the routing algorithm just covers barangays within the regions that you've specified, right? I think the I just want to point out, no, because it might be that setup of same region routing of barangay to hospitals might not apply, especially in NCR, because for a fact we know that other provinces, people from other provinces go to Metro Manila hospitals, so the travel time could
Yes.
be much worse, and that's traffic excluding. So that's
Yes.
further compounding factors on the accessibility of hospitals. So that's it. Overall, very good job. Good job. Very thorough explanation of our medical field hospital needs situation right now. Thank you.
Thank you.
Okay. Hi, Ruth. So this is Enzo.
Hello.
Yeah, so thanks for that presentation. That was very strong messaging, as JC said. Maybe just before I ask my question, I think the slides were there was a lot of information. May just suggest like one recommendation around the comparisons. So there were a lot of slides that were focused on comparing numbers across regions. I think for some of them, it would have been better to utilize, let's say, a simple bar chart, especially during the times when you were trying to emphasize rank. So a simple bar charts just showing like in descending order, that would have been great. But in overall, I think I was able to follow. Just one question for me is, I understand that one of the goals of the presentation was kind of to pinpoint, what are the hotspots where we should put hospitals, and of course, like we should have hospitals everywhere, right? But then, in reality, we have a constrained optimization problem where we have a fixed budget. We need to prioritize certain provinces. So, which province would you start with if you had, let's say, a budget of, I don't know, how much does it cost to make a hospital? Let's say ₱1 billion. Where would you build it first and why? Based on like just the overall insights that you gathered.
Definitely it would be in ARMM so that we can reduce the number of people sharing a hospital. Because based on the analysis, ARMM has the least number of hospitals as compared to the population. So, yeah. So that
Right.
would be ARMM.
Right. So it'd be error. Okay. Yeah, I think that's good for me. Thank you.
Thank you very much, Ruth, for that presentation. So, in addition to our physical health, there have been reports of an increase in mental health concerns because of the pandemic.
Yes, this is definitely not an easy time for all of us professionals and students alike.
So, our fellows know this firsthand what it's like to learn in an online learning setup and how stressful it can be.
So this is why in our next presentation, our two undergrads, Franz and Fonso, will share with us their findings on the impact of the pandemic on our mental health. Let's watch.
Hi, I'm Franz, and this is my partner Fonso, and we set out to understand the Filipino mental health situation during quarantine. So, a lot has been going on with students and their learning, typhoons and their effects, of course, quarantine and the political climate right now. And everyone always talks about masks, medicine, food, but what about your mental health? Like, how are you? How are you feeling? So, Fonso and I first asked, how can we help those with mental health illnesses during the pandemic? And then we transitioned to how is the mental health state of the Philippines during quarantine? So we started by answering, how can we truly understand the Filipino situation right now? So we started by gathering data using Twitter and a survey, and then we created our own features using time series and sentiment to further explore and visualize what we found, and then we tried to further understand by trying to model it. So these were the tools that we used. we were restricted to Twitter for our main data source, and of course, it has limits on its correlation with mental health. For our data set, we had a relatively small one with around 150 clean and with consent. And we want to stress that we are not mental health professionals and we are not aiming to diagnose people, nor do we promote self-diagnosis. And for the time, we restricted it to 6 months before and 6 months after quarantine. We also want to say that there might be trigger words in this presentation.
Right, so how did we get our data? So for our purposes, we ended up using SNS Scrape. We would have used more popular Twitter scrapers such as Get Old Tweets 3 or Twint. However, recently Twitter changed something on their front end, and so most of these scrapers are either partially or completely broken. Next slide. So next we look at the features that we explored. And first, of course, is just our demographics that we got from our survey. We also looked at time series features based on the tweets that we got. We also used sentiment analysis to check whether a tweet was either positively or negatively sentimented. We also looked at Twitter metadata, which refers to the overall user activity, such as their location, the number of followers, number of following, etc. And we also wanted to ensure data privacy, so we only dealt with Twitter IDs and not their actual handles.
So we looked at demographics and their inherent biases. So our data set mostly came from people aged from 18 to 22, and they're mostly students. And for location, it's mostly from Metro Manila and a mostly female data set. So this isn't, this might not represent the entire Philippines as of right now.
So next we wanted to look at, the user activity basically, and here we plotted out basically the sentiment of their tweets overall. And as you can see, it's somewhat a 50-50 split, although more negatively sentimented. And if you look at the pre-lockdown and post-lockdown splits, post-lockdown tweets are actually slightly more negative than they were pre-lockdown. So this blue line in the middle refers to the start of the lockdown. And as you can see, people on average are tweeting more after the lockdown, which makes sense, since we're all at home, people are probably have more time to tweet basically. Next slide, please. Right. And then one of the interesting things we found is that during the hour that users tweeted the most, so basically when people tweet a lot in a short amount of time, the tweets are actually generally more positive than they otherwise would be. And then on the other end of that, when you look at the tweets after the longest period of inactivity per user, you find that these tweets are almost completely negative. And so it might just be, a good reminder to check in on friends who have been exhibiting rather strange tweeting patterns, I guess, on Twitter, since they might be going through a difficult time. Next slide. Okay, and then here we created a word cloud of the uncensored words from all of our users. From this itself, there's not much you can get. There are, very common words, of course, such as love, thank, friend, that are used a lot. And when we tried to look at these word clouds and segregated them both pre-lockdown, post-lockdown, positive sentiment, negative sentiment, we found that the word frequency actually stays mostly the same, which for us was pretty surprising because we thought, there would be a bigger shift after the lockdown. So we decided to look closer, and we decided to look at the 1 month right after quarantine started. And here are some of the selected words that we found. But all of these words are from the top 100 most frequent words. And particularly, we found government, quarantine, COVID, Duterte, as to be expected. And we also found words such as first impression, closeness rating. And the thing is, these words are used in Twitter games, which makes sense given that our demographic is mostly students. So yeah, I guess during that time, it was very popular, I guess, as a sort of a lighthearted way to pass the time, given the troublesome situation at the time. So next slide. Okay, and then next we're gonna talk about our modeling. So given, the overall Twitter activity of one user, we then decided to try and flag. We wanna specify that we're trying to flag and not diagnose depression and other mental issues here, particularly because it is very hard to diagnose. So our target variable is, whether they have been clinically diagnosed with depression or not. And basically we tried out a bunch of different machine learning models to come up with the best model that could predict this. And on our next slide, right, so here's just basically a breakdown of how our model performed, and it had overall about a 70% accuracy. And the next slide. So on our next slide, we show
the top 5 features that were most important to our model. And we just want to highlight the top one, which was actually number of media posted, which is a bit surprising to us because this feature basically tells you, how many pictures or videos does this person share on their Twitter. And we just thought it was very surprising that this was the most indicative feature for our model. So next. And then for our insights, so first off, we just want to say that diagnosing mental health issues are very difficult. Particularly, there was one study from Johns Hopkins that said that up to 60% of those with depression are misdiagnosed. So yeah, given this difficulty, we think it might be a good idea to try and use technology, particularly social media analysis, to help as a tool in diagnosis, since it is something that even medical health professionals really struggle with.
And something that we are sure of is that the online activity of Twitter users has definitely increased and actually stayed constant after quarantine. We can also say that, of course, mental health is complex, but we only delved into the simple methodologies. But right now, there are scientific methods that can potentially help mental health professionals. So there's definitely a lot to improve, especially with this project of ours, but it will take time and help from a lot of people. And we also want to highlight that we ended up studying mostly the pandemic's effect overall on the behavior of users as a whole because of the impending shift to the online environment.
So for our next step, we mostly want to focus on using NLP better because as it is, the Filipino language isn't very well supported by the current NLP libraries. Particularly, we think we could have used more sentiment analysis to improve our models.
And yeah, just more improved data collection and a better survey, more comprehensive, and maybe even look at other social media, as well as deploying it into something tangible. So maybe a product that sends hugs or motivational images and hotlines to people who are flagged on Twitter using a bot. For our documentation, everything is up on Notion, all of our notes, all of the process that we took, and we'll be releasing a Medium article soon on in-depth methodology. Our code is available, but the data will not be included, as well as any sensitive information. And we want to further improve on this project, so we call to mental health youth organizations that are watching right now to reach out to us using our emails to maybe start by launching a campaign for awareness on Twitter using this data and maybe actualizing it in the process. So a lot has happened to us, to our fellow Filipinos over the past few months, but we want to remind everyone that the mental health of each person is just as important as their physical health. So we appeal to people in schools, workplaces, and the government to understand that. And we want to remind people to not be afraid to reach out. And yeah, thank you so much for listening. Stay healthy and safe, and let's enact change together.
Okay. Hi, Fonso and Franz.
Hi, JC.
Thanks for that very timely presentation, and thanks for pursuing this very relevant topic. Not everyone actually has the guts to tackle this in a data science perspective. No? And thank you also for your care in interpreting the results, since you're right, only qualified medical practitioners can diagnose such cases. No, so my question would be on the scraping exercise and about the sentiment analysis that you did. So as you may have known in the documentation of the libraries, the relevant libraries for that, the algorithm is based on an English corpus. So how did you deal with Filipino or Taglish tweets, and what percent? I assume you dropped them, and I'm just curious what percent of the tweets you scraped were from those categories.
Yeah, so that was, I would say, like one of the bigger problems we had because yeah, like I said in the video, like the Filipino language isn't really supported that well by the current NLP libraries and stuff. So yeah, we did have to drop them. So all of the plots and stuff we showed were on English tweets. And yeah, it was hard because that was a big part of our data set, like maybe around half. And although, yeah, we dropped, like Twitter actually has a language feature. So they're already split up into English and Tagalog. Although even that in itself isn't that accurate because, yeah, I mean, most people use Taglish and that kind of falls in between English and Tagalog, and there's no real like label for that. So it was a bit difficult, yeah.
Okay, cool. I can next. Oh, sorry. Are you done, JC?
Yes, I'm good.
Okay, cool. Yeah. So for my question, is more of like follow up on also on the tabular side. So it's definitely a challenge. This is something that NLP practitioners in the Philippines would relate to a lot, especially working with social media data from the Philippines. So if you had more time, do you have what would you what kind of approach
Hello, sorry.
Cut off.
Oh yeah.
Oh, okay. So I think Lorenzo is off the call.
Hello.
So maybe, there you go. Okay, we can
Am
hear
I
you now.
back?
Yep, you're back.
Okay, sorry. So I was asking, how would you, because we eventually want to include Tagalog also, right? Or in Taglish as well. So what would be your next steps to like making sure that happens? And after that, like I can recommend some next steps as well. Yeah.
Okay, so I think I can answer that. For our training data set, we actually used the NLTK positive and negative tweets. So for our next steps, we would definitely want to include the Filipino side from that. So I actually talked to peers at Ateneo about that, and they were already talking about classifying those kinds of tweets kind of manually. So maybe we can incorporate that as a next step. So as we said, we appeal to work with other mental health organizations right now. So that would be a step. And then, of course, we also want to look at how Filipino hashtags are used. So we weren't able to discuss it, but we looked at some Filipino hashtags and tried to analyze them, but we had to incorporate stop words by ourselves. So it was a bit hard. So yeah, definitely if we had more time, we would spend more time by cleaning that and working towards it.
Understand. Yeah. One approach that actually some people take as well is like, and it's not perfect, right? But it kind of works for some Tagalog NLP practitioners. Is they augment the data sets by labeling them based on the emojis, right? So let's say, so the idea is that if you have very very positive emojis, then it's probably a positive tweet. If you have very very negative emojis, then it's probably a negative tweet. So there will be some noise there because sometimes there's sarcasm. Sometimes people say, like stuff like that. But then I could also like recommend that as like a middle kind of step. But yeah, I also agree that I just wanted to share here also that countries around the world have these like sentiment models for their languages because people have contributed data sets and labeled them. Right now, it's a challenge in the Philippines that we don't have those communities yet. So if any of you want to like spearhead those, join the communities or trying to do it, that would also be super great. So yeah, thanks so much. Great work.
Thank you.
Thank you.
Okay, so great. Thank you very much, Fonso and Franz, for your presentation. So Thea, we're down to our last presentation. I've learned so much already from our fellows.
I've learned a lot today too, Rick. And you know what they say, knowledge is power. But that's not the only kind of power we have. There's also a kind of power that lights up our homes. So Rick, do you have any idea what power I'm talking about?
Well, of course, it's electrical power.
Bingo! You got it right. But would you know if there will be enough electrical power for us in the coming years?
Well, to answer your question, Thea, our next group will be sharing the results of their study on forecasting power demand in Luzon. So let's give it up for the last group, Jaleel, Jonas, and William.
All right. So good evening, everyone. Thank you for being with us tonight. I am Jonas Beltran, and together with my mates William Revilla and Jaleel Villena, we will present our capstone project entitled Forecasting the Power Demand of the Luzon Electrical Grid Using Clustering and Predictive Modeling. So let me paint you a picture on our motivation for this project. Last March 2019, next slide, please. The grid was operating in such low reserves that there's only a 624 megawatt difference between power supply and demand. And in fact, the average power supply and demand throughout the whole of 2019 had a difference of approximately 1,000 megawatts only, which is dangerously close and threatens our energy security. Thus, our study is significant now, since forecasting power demands not only serve as a foundation in the planning and construction of infrastructure for additional power generation, it also establishes our energy security. In addition, it is a good indicator of our economic growth. So for our first objective in this study, we need to gather the data from the website of the Independent Electricity Market Operator of the Philippines. And next, when we had this on hand, we needed to perform an exploratory data analysis to clean the data set and formulate general insights from it. Clustering proceeded next, and for this, we used multi-layered clustering algorithms to determine the most sensible combination of resources that belong in different sectors. And lastly, time series forecasting models were applied to the cluster data to determine future power demand, both in total for the Luzon grid and the different sectors. Our tools that we used to accomplish this were Python, Jupyter Notebooks, stats models, and Facebook Profit. So for our EDA process, here is Jalil.
So we started with almost 5 million entries of data on 264 resources from Luzon and Visayas. A resource is the interconnection point between entities such as power suppliers and consumers and the electrical grid within a local area. We then narrowed it down to Luzon data with only 2.4 million entries on 183 resources. We cleaned our data mainly by removing duplicates and by setting a threshold of 5 megawatts of total power demand in order to eliminate those resources with low total demand throughout the dataset. So we first looked at the historical total daily power demand of the Luzon grid. An electrical grid is where producers send electricity to their customers. Looking at this chart, we saw intuitive trends like how we consume more electricity during months with higher temperatures and vice versa. We also noticed the effects of specific events such as power outages and holidays, but the largest influence on our data came from the effects of the quarantine brought about by the pandemic. Comparing power demand on the per hour basis, we verified that on average, power demand decreased during all hours of the day, especially during office hours. This is attributable to the closing of offices and public places. Analyzing more granular data, we noticed that the behavior of resources vary. And as seen on the charts on the left, these peculiarities are washed out when looking at Luzon as a whole. We were then able to see patterns in resources and noticed similarities among them. This will be further discussed by Jonas in clustering.
All right. So after our EDA process, we subjected the data to another round of pre-processing to normalize the median megawatt value per resource per hour. So this resulted to our database to have our number of sources to drop to 153 from 183. This was done in order to focus on the daily movement of the power demand of each resource instead of its magnitude. Clustering algorithms were then used to segregate the resources into their sectors, with hierarchical agglomerative clustering yielding the most sensible results. The output of this process was a total of 6 distinct clusters. Next slide, please. The residential sector included 59 resources with an average of around 26,000 megawatts power demand in between them. And the next one had 17 resources, and these belonged to various sectors. And they had an average of 5,800 megawatt demand. The commercial sector had 59 resources as well, but took the huge bulk of the demand at around 153,000 megawatts. And the power generation units had 6 resources and an average of 4,400 megawatt demand. And for the industrial sector, next slide please, they had 3 resources and an average demand of 880 megawatts. And lastly, another commercial sector had been detected, having 9 resources with an average demand of 4,200 megawatts. The main difference of this one from the first one is that the activities for this particular cluster are more pronounced in the evening, suggesting that they must have been commercial offices working during the graveyard shift. So the following figures show the average total demand per day for each of the determined sectors. And now we will proceed into forecasting, and here.
Okay, so now we can proceed to forecasting. To illustrate, this is the time series data of the daily power demand of the Luzon grid of the 153 resources that we considered. Next, please. The first model that we ran was ARIMA. It is generally an acronym that stands for Autoregressive Integrated Moving Average. And here we ran it on the 6 clusters that we have identified. And as you can see, it roughly forecasted a straight line. Next. We again ran the model for the Luzon grid where it showed a similar behavior where it again forecasted an almost straight line, and we'll also get into why that happens later. Next. So now knowing that ARIMA did not work, we tried a different model called the FB profit model. Here we ran it on the 6 clusters. And if you look at it visually, the forecast period roughly follows the same shape compared to the same period of last year. Next. And as you can see, looking at the 6 cluster, the sudden drop and sudden spike when lockdown was implemented and when it was lifted produced a forecast where it skyrocketed. Next. So now we look at the forecast data when we sum all of the results of the forecast from the previous slide. Next. So here we see the results when we run the FB profit model for the total daily power demand of the Luzon grid. Both of their forecast periods shows a roughly similar shape compared to the same period of last year and roughly the same values. So now we go on to the model overview. To roughly answer why ARIMA forecasted a straight line, it's because the time series data that has a weak seasonality would often result a straight line forecast. And our data not being stationary where the mean, variance, and autocorrelation structure changes a lot over time, and this is evident on the sudden spikes and drops that shows no patterns over the dataset. FB Profit, on the other hand, considers the trends, seasonality, cyclic patterns, and even irregularities in our data. It works well with missing data and flexible with sudden dips or spikes in the data, which is why it worked better than ARIMA. Next. So to conclude our results, the Luzon electrical power grid forecast suggests that electricity demand is normalizing, but a 4% increase is observed in demand. Next. And for the 5 clusters, for the forecast of the 5 clusters suggests that their respective sectors are normalizing, and the 6th cluster that we have identified show the forecast behavior where it just continues to rise since that cluster is identified as a commercial sector where night shifts are prominent. The sudden drop and sudden spike during the lockdown and when it was lifted caused the model to predict its future values to continue to increase and has not normalized. Next. So some recommendations that we can do is to increase our historical data. A longer data set is always going to help with forecasting, and improvement of the models through K-fold and other validation methods will allow us to select better model dynamics. Another thing we can consider for the FB profit model is incorporate special holidays or events in the forecasting since it could take those into consideration when encoded. And on future studies, we could incorporate the supply side of things to see if our industries could actually keep up with the demand. Next. So to end this presentation of ours, here are our insights on what we could start supporting when it comes to energy, such as a call for better infrastructure to prevent power outages and meet our current and future demands. Stakeholders could also invest in renewable energy. Next. And for our roles as a citizen, we could always avoid the use of unnecessary electricity usage since we often take it for granted, not knowing that our demand is starting to catch up with our supply. And for those who can, we encourage everyone to invest in renewable energy systems to power their needs. And for everyone who wants to learn more about the process we did to this study, we will release a full documentation soon, and you may contact us through our LinkedIn profiles here. So thank you, everyone. We are now open to answer your questions.
Okay, I can go first. Just making sure, does everyone hear me?
Yeah.
Yes.
Okay, cool. So first, good job. Like I definitely understood the charts, but also because I'm from a time series background. I didn't notice metrics reported for like error. What was the error metric you used and why did you choose that?
RMSE, but we mostly relied on the visuals. Since if you were to look at our forecast, the way that we approach this is to just minimize the upper bounds and the lower bounds, and that was successful in the FB profit model. Although we really did not provide a numerical value for this presentation.
Right, got it. So just follow up to that. So I would recommend that you also perform. So did you perform any out of sample comparisons using did you measure the accuracy of the out of sample predictions of profit? Right. So I noticed earlier that you did the dark forecast. So you did the out of sample forecast far into the future, and you used that as a recommendation. but did you measure the accuracy of the out of sample forecasts using a holdout set?
That we did not for the study.
Right. So
Yes.
I would just, so that would be my main recommendation. My main recommendation is for you to do that, because that is actually the most important accuracy metric that you get. Because in the
Oh.
context of policy decision making, so you showed like the scatter plot with the lines, but that actually shows, I believe with Facebook profit, that's like 1 day ahead forecasts,
Yes.
right? So the errors would just be 1 day ahead errors. But in reality, when you're doing planning, and I worked with energy data a lot before. In the context of planning, you don't, the relevant error is not daily error, right? It's typically months in advance error, or even quarters in advance error. Because what is the policy decision that actually is actionable, right? It's building a power grid. It's maybe providing support, providing subsidies in a certain area in the country. And those are things that take time. So yeah, so I would just recommend that. But great job overall. Good job, team.
Okay. Thank you.
Thank you.
Hello. Hi, Jonas, Jay, and Will. So
Hello.
I'd like to commend your group,
Hi.
guys. This was a very comprehensive presentation. I like to point out that you guys did explain all the details quite well, while not missing out on the significance of what you're doing, relating it to the electricity sector and what us as a consumer experience. No? Ha. So, just a few comments on the clustering. I've noticed some of the clusters have few members, so you might try to
Yes.
explore bunching them into the other larger clusters, so that might improve the predictability of that particular cluster. Also, I could verify that coming from the electricity industry, the energy industry, that the insights on the time series was consistent with what we saw in the market. The Philippine, at least in your case, it's just Luzon. But in the overall, the Philippine demand is actually has recovered or around that level, pre-pandemic level already. So good job. It checks with what we know. Just on the forecast, no, some of the forecasts were, I guess, too high. It's not for your fault. It's because you're forecasting using Facebook profit for a very long interval. Usually re, we put in more input as they come, but you don't have that since you only have historical data. So what my suggestion would be is to explore some constrained forecasting methods. So maybe on top of Facebook profit, you could pass this forecast to another forecast that uh, takes into account the constraints from previous historical data, and then that could give you a more realistic prediction.
Okay.
All right. Thank
Thank
you.
you.
Thank you, everyone. Good job.
Thank you.
Thank you, JC. Thank you.
Thank you, Lorenzo.
Thank you, Jonas, Jolel, and William. And huge thanks to Lorenzo and JC for being part of our demo day and for judging our fellows' presentation. And that's it from our fellows and their projects. So I have one question for our audience is that are you interested in creating your own capstone projects? So stay tuned to know more about how you can do this. But first, we'd like to ask you to vote for your favorite project by filling out this short form at bit.ly/demo day capstone vote. So again, that's bit.ly/demo day capstone vote. So while we wait for your votes to come in, I'd like to ask you the same question, Rick. Which one was your favorite project?
Well, Thea, my favorite project was on the research areas in physics, mostly because I was the mentor for it. But on a serious note, it's pretty cool to know the latest trends in the sciences and how the Philippines is hopefully catching up with its neighbors in research output. So, what about you, Thea?
Uh, I can't really decide because they were all really good and they're very, I guess, significant to the time that we're having right now. But if I really have to choose, I think I'll go with the gift recommendation presentation, especially since like Christmas is right around the corner, just like 27 days to go. So like I can just share this wish list to anyone who's asking about what I want for Christmas or even if my birthday for next year. Just like, hey, here's the link. buy me gifts.
Oh, okay. Look, so we see a lot of votes coming in right now. So keep voting, guys, because we are going to announce the audience's favorite capstone right before we end the day.
So that's right, Rick. Like, just keep on voting, guys. The link is here flashed on the screen, and also you can find it down below in the comment section. So, after all the typhoons that recently hit our country, and on top of that, my pandemic pa, diba? Like,
Oh,
it's
nga
still
eh.
going. So, I'm thinking that we need more people that work on projects for social good. So, Rick, do you have any recommendations on how we can use our data and tech skills to make an impact in our society?
Well, great that you bring that up, Thea. So yes, actually, that's the main goal of Omdina, our partner org, to use AI and tech to solve real-world problems. But because Omdina's collaborative space caters globally, and they are currently located in California, our guest speaker, Lucy, can't make it live due to the time difference. But that won't stop us to meet her, as she prepared a short video explaining what they do in Omdena and how we can participate.
That's right, Rick. So Lucy actually has a background in technology consulting, ranging from big data analytics to pharmatech, mainly in North and South America, having most recently gotten more involved in the impact space. So she is a strong advocate for diversity and believes it is one of the driving factors of success throughout all areas of life.
So Lucy is also joined by Bash, who is part of an Omdina project just this year, and later on, Bash will share with us his experience with Omdena. Let's give it up for Omdena and Lucy.
All right, looks like I'm recording now. Hello, everyone. I'll be talking about Omdena today. I'll talk about kind of the motivation behind Omdena, history of Omdena, where we are now, and how you can get involved. So just to start, I'll give you an intro, brief intro of who I am. So my name is Lucy. I'm the head of community at Omdena, and what that means is that I'm responsible for the overall growth of community and of the community. And what that means as well is that whatever projects that we host from our platform, if you complete one, you join the community and are there, have an opportunity to get access to the opportunities that we offer from within. And that's why the reason I'm here as well, right? In order to grow the community with people like yourselves. And we'll actually be hearing from Albert, who is an alumni of Eskwelabs, and he worked on one of the Omdena projects quite recently. So that's going to be interesting. All right, so just to give you to start with a background of Omdena. So we were founded around 1.5 years ago by Rujadeb Mitra. He has been in the AI industry for a long time, and his main motivation and inspiration was, number one, to build AI for social good. And then second, make AI accessible to all people from around the world with different levels of experiences and different levels of exposure, and to foster an environment of collaboration, global collaboration over competition, because that's what's required to build ethical, efficient, and scalable AI solutions. And ultimately, the goal of Omdena is to really change the future of work and education. So in order to kind of put those motivations and those ideas into practice, Omdena initiated their very first project in order to use this model of global collaboration to identify solar capacity of rooftops in a city in India. So what that entails is, you see here on the left, all of the rooftops in India are quite fragmented and also close together, hard to distinguish with the human eye, let alone with a machine, versus the rooftops we have, for example, in Europe, that are easy to distinguish and highly accessible. So this was a big problem to solve. No solution was on the market at the time. So it was quite a challenge to approach. So initially, obviously, what happened was, as with every data science project, the need of a data set was very, very important. So how they started was they selected a group of 60 to 70 students. data scientists, machine learning engineers, and domain experts, and utilized that manpower. And these people came from different regions within India, because this was an Indian specific solution for the Indian market. And all of these people kind of knew about the rooftops in their neighborhoods, their friends' rooftops, and they started tagging the rooftops and quite quickly building out a huge data set in order to train the models on. So what are the results? Within a 4-month period, they were able to build models from 80 to 85% accuracy. They were pretty much the first solution to the market. So just to put it in perspective, Google Sunroof is not able to identify rooftops on low resolution images. So that they were able to achieve this on such low resolution images was quite a success, right? To identify the potential kind of the area of solar panel installation on these roofs. So it was quite a success. And if you think about who was involved, these were around 60, as I mentioned, enthusiasts from diverse backgrounds, from different areas of India, who built these models through community collaboration. And these guys weren't PhDs, weren't data scientists with many years of experience. They just were very connected to the problem and worked together to build a solution around it. So fast forward to where we are now. Now we have around 34 to 36 projects that are ongoing. We've had over 1,500 machine learning AI engineers, data scientists, domain experts from across 86 countries work on our projects. So we've stayed true to kind of the core of diversity and global collaboration since the very start. And when you think about, you know, how do we host these projects? We host these projects in the form of challenges in partnership with large corporations, small corporations, public-private corporations. A few examples here you can see on the slide. We've worked with a lot of big NGOs like Save the Children, World Food Program, UNHCR, World Resources Institute, and then of course some smaller startups or social enterprises like Zap Malaria, Credix, Synthesis, Engie Factory. So these might be less familiar to you, but the point is that we've collaborated with various partners to solve these types of problems. And how do we achieve this? We achieve this through a few different aspects that we see in all of our different project teams. So first, we have autonomous teams, right? We're bottom-up collaborative platform where we have autonomous flat structures. Our teams comprise of multidisciplinary and cross-functional talent. The high diversity, and why that's important is that we see that the high diversity really leads to bias mitigation in the solutions that we build. And ultimately, what we're able to achieve with this vast amount of people is in one project, there's a lot of experimentation and rapid iteration in order to achieve our desired results. And what's the representation that we currently have or we see on any given project is 35% of lead engineers are women. We have representation from various continents and different countries within those continents, as you can see here, Europe, North America, Australia, all through Asia. The age groups that we see on our projects are anywhere from 18 to 65 years old. And as mentioned earlier, years of experience, what's really important there is that our project teams have anywhere from 1 to 7+ years of experience in the domain or in the field. So now we can get to the spot where we talk a little bit about how Umdena works and how you can get involved, how that process works. So first of all, if you visit our website, and I'll share that website at the end, but an organization submits a problem, a use case, or an idea, we help them formulate the problem and host them in the form that you see on the screen as an application for external collaborators to apply to. So if you go to our website right now, you'll see 4 projects that we have for the rest of the year, all very various. So 3 of them are with NGOs, and then 1 of them is actually with a startup, the Detecting Weed to Reduce Costs. So here you'll see a variety of computer vision needs, right? So the weed one and the crop classification one are focused on computer vision, while the other one, like the predicting infrastructure needs in Africa and the accelerating not-for-profit funding, that's more predictive analytics and data visualization. So we really have a wide variety of skills that you can kind of leverage for each project. Next, we select, based on our applications, we select around, excuse me, we select around 50 to 60 collaborators for any given project. We kick off the 2-month project, so it completes within 2 months. And what the team does within those 2 months is that they refine the problem statement, start collecting the data, and start building the solutions, leveraging our processes and the Omdena tools, processes, and knowledge base, which comprises our platform. So then how does that look when you start a project? As mentioned earlier, what we don't look like is what you see on the left. So we're not a hierarchical pyramid. What we are is a network of team within our project. So if we, within any given project of 50 to 60 collaborators, within the first few weeks, you guys will self-organize into different task groups. You'll identify what tasks need to be completed in order to solve the problem. And then you'll work together in form of, sprints or weekly meetings in order to achieve those goals. But you're welcome to take up any role that you see fit or contribute as much as you want, because that's actually what we encourage and try to foster. So why is that important that we work in networks of teams? Is because this is how we see faster AI model generation. As you can imagine, multiple models can be tested in parallel through sub-communities and task groups. And this leads to ultimately more models being tested and built, and therefore a bigger pool of models to choose from when you want to prioritize accuracy over quantity. And now, just to finish it off, I'm gonna just talk about 3 of we have all of our case studies on our website. You'll get to see all of the completed projects, case studies involved, how we came up with the solutions. But just to give you kind of an overview of 3 of our projects that we've completed, they're really wide ranging, from AI and route planning to satellite image analysis and NLP. This first one here, we did it in collaboration with Impact Hub Turkey. They have quite a few earthquakes, so we got a team together to figure out, build a tool that will allow families to reunite when earthquakes come, right? Figure out the best route to get back to your family in case of an earthquake. So that one's using route planning. And then the second one here on the right was with a startup in Brazil. And this was to utilize satellite imagery in order to identify forest fires and in order to predict them, in order to mitigate that risk. And then the last one down here you'll see is more of an NLP use case. So this is where we got together with an NGO in the US in order to utilize NLP and do some sentiment analysis on tweets in order to identify, whether or not there's a correlation between tweets and where the next gang violence is going to occur in the city of Chicago. All right, so that's pretty much it. I hope that sparked your interest a bit about who we are, how we came about, and kind of the projects that we're executing. Again, any more information that you see, you can just reach out to me on LinkedIn. I'll have Janica share my LinkedIn with you guys, or just follow up on our website or blog. Thanks for having me.
Hey guys, thank you, Lucy, for giving an introduction about Omdana. So again, I'm Albert. I'm one of the instructors for Eskwelabs, and I'm also one of the machine learning engineers in Omdana. So I just finished a project with them recently about how we can combat malaria using satellite images data. Um, Thank you guys for having me tonight all the way from New York City, Cubao. So I'm gonna share with you just the highlights of our results. I can't really share the whole pipeline because it's a lot to absorb, but I just want to pick your interest now on how you can start partnering with with Omdena if you want to do some projects with us. So here are the things that you might be learning along the way in collaborating with other people. Okay. So first, common in a data science pipeline, right? You first define your problem. So the first thing that we did is that we did an analysis of what's happening globally in terms of the cases of malaria. So we saw that malaria is still prevalent in most countries in Africa. So that's why the motivation of why we do this project is collaborating with existing NGOs already in Africa. So I am also passionate for solving this particular problem because I want to take this technology back to the Philippines because there are still lots and lots of malaria cases in northern Mindanao and in Palawan. And I'm really much interested in how we can use these same algorithms to help save lives of Filipinos as well. Although malaria is prevalent in different places in the world, there are many things that we can do to solve the problem. And one approach is to treat water bodies where the larval stage of mosquitoes develops. So it's similar to what we do here in the Philippines, but they have different formulas because there are many different species of malaria carrying mosquitoes. So what malaria is doing in Africa is being solved by one of the NGOs called ZAP. So what ZAP is doing is that they take in satellite images, they divided these satellite images into grids, and they ask volunteers, local communities to walk and uh, monitor the water bodies that they see along the way. So while monitoring the water bodies that they see along the way, they measure through sensors, through some gadgets that they have, the pH of the water, the number of possible malaria eggs that can be found in those water bodies. However, ZAP faces common problems like the grids are really huge. So they do need a lot of manpower to do it, and it entails a lot of cost. So what we tried to do for this project is that we were looking a way for us to automatically pre-survey the area using satellite images. In essence, we want to identify possible water bodies based on satellite images. So here's our objective. Given a region, we need to automatically identify areas where there are water bodies so we can do a cost-effective way to survey the area and use artificial intelligence to georeference the locations and find water bodies. So the good thing that I learned in Omden is that you work with a lot of people. A majority of the collaborators that we have for the project, they're mostly based from Africa. So that's a good way for me to learn from various backgrounds as well. Learning from diverse groups of people really opened my mindset into different kinds of solutions, different work ethics, and so on. So I really enjoy the process of collaborating with different people because the things that I do might be different from their approach, and it's a very cool learning experience. So given the problem, what we did is that, as Lucy mentioned a while ago, we rely on self-organization. So self-organization is a theory in complex system where aggregates or agents just collect by themselves. So what I did is that I volunteered to certain tasks. For example, I am primarily focused on doing image processing for them and modeling. So that's my main task for the group. I did not necessarily handle the consolidation part, but I did specific tasks for the group. Here are some of the pipelines that we used for the tools and how we were able to solve the problem. So as you can see, some of the things here we already use in Eskwelabs. Some of the things here, I mean, a lot of the things here we already use in the Philippines. So the talents that we have here in the Philippines is not like actually far from what's happening abroad. So the skill sets that they have is similar to what we are having here in the Philippines. So in our modeling phase, I will not really like detail the models that we've done, but here's a sample pipeline of how we did image extraction. So what um, I really had fun in doing the image pre-processing because I had a physics background. So as a physics major, I did a lot of image processing during my research times in university. So my particular task is doing an algorithm to do histogram manipulation and histogram equalization. So what does that mean? So basically, given a blurry image, I can enhance the images by just enhancing the individual pixels of that images. So that's really interesting. So here are some of the models that really work for us. The interesting thing that we did is that we re-implemented some of the state-of-the-art models, the state-of-the-art research publications in this area. So that's really interesting that in just 3 weeks, you were able to replicate a full-blown science research published by established universities and research institutions. So one of the models that really work for us is called the spectral unmixing. So it's not the typical machine learning model. It's not the typical AI model that we use in industry that we have labeled data that we can use as our metric to identify our accuracy and cross-validation, so things like that. So what we did, we tried an unsupervised machine learning approach. So each pixel, we did not need to label that pixel. We just used mathematics to break down the components of that pixels, as you can see here in the left. So we use the classifications of those pixels because a pixel is composed of many channels, right? So for example, if you like look at your computers, you like put a droplet of water in it, you can segregate it into its components like the red channel, the green channel, and the blue channel. So we use something similar, but the satellite images are not as simple as that. So the satellite images that we've used are 19 bands, or there are many bands other than the red, green, blue channels. There are some channels like ultraviolet, like cloud mask, and things like that. So by doing multiple iterations of and mathematics across those bands, we were able to do this model. So we were able to successfully validate that this type of algorithm models, AI algorithm models, we were able to identify around 95% accurately that there is an existing water body in that area, not only a water body, but also a water body that is is of interest of us in terms of its capacity to for malaria cases. So the thing that I've learned throughout the process that I am involved with Omdena is that the future is open collaboration. The future is innovative collaboration. We are really growing into a culture of learning. There's so much things available online. The resources are there. And as such, we see that the trajectory of us as data scientists, we are becoming more and more of global citizens. So you can see that in the future, you will not be only collaborating with fellow Filipinos, but collaborating with different kinds of diverse backgrounds around the globe. So it's a way for you to head start your journey for really like future proofing yourselves in terms of the future of work, and in terms of the relevance of the problems that you're solving. So I'm happy to share the things that I've done with Omdena. I'm looking forward for more projects. And I'm really happy to tell you guys that some of our students in Eskwelabs are already part of our future projects in Omdena. So that's really interesting that we can do more and more of the projects that are relevant to our society using these kinds of platforms. So thank you guys for listening. I'm sending you all light. I'm sending you all love for our fellows. Just be you guys. The universe needs more of you. Thank you.
Wow, Bash, you're doing really cool things over at Omdena. So, as someone who works in social good projects, it sounds so interesting to me. So, I bet our audience has questions for you as well. So, feel free to ask Bash by writing your questions on our Facebook comment section below. But to start off with, let me ask the first question. So, out of all the diseases in the world, why did you focus particularly on malaria?
Well, it's not actually my choice. It's actually it depends on what NGOs are approaching us. So yeah, just Zap approach us. So that's what is relevant for us. But definitely, like if you look at statistical data, a lot of lives are really like taken by malaria still in our times. So you can see the disparity of technology. Even though we are so advanced as a society, the advancement still produces disparity in our classes. Like for example, we are now approaching a solution for the vaccine for coronavirus, but still these kinds of diseases that are ages long are still prevalent in these countries, and that's really sad. But we are still hopeful because there are lots of like-minded people who are able to address these things using collaborative innovation, using science, and yeah.
It's really great, no? So you did mention that you wanted to bring back this technology here in the Philippines. So how do you think it would look like for us, or like how can we start with this?
Yeah, we need to partner really with organizations that are already doing this. We need not to start from scratch because there are already like developments with this kind of like approach here in the Philippines. For example, if you're familiar with Seralytics, they did a similar approach of detecting dengue using satellite images. So if we can consolidate those kinds of efforts and communicate with our stakeholders, such as LGUs, such as the government offices, that could be a great plus. And uh, the technology that I was referring to you guys a while ago is not only applicable to like solving malaria, it can be expanded to a lot of applications. For example, I had a talk yesterday with Pista ng MAPA 2020. The methodologies that I used for mapping poverty in the Philippines, I got it from, I learned those tools that I did in that project from Omdena. So that's really uh, applicable to many areas as well.
Well, that's really great, no? I just wanted to ask lang siguro with your experience in Omdena. So, although Lucy touched upon this earlier, so as someone who is part of an Omdena project, how do you guys work together, given that there are 50 plus collaborators?
Yeah. At first, I was overwhelmed. I was culture shocked. I didn't know what to do because the first day of work, there's just a Slack group, and I don't know what to do. Like, oh my God, people are chatting, and I don't know what they're talking about. They're talking about tasks. I can't relate. But the good thing about this is that it's really self-organization. So you really need to be proactive. You need first to be really interested in the problem that you will reach out on your own. Like for example, you will own certain tasks. You will coordinate with people. If you see someone posting there, coordinate with that person. So that's a cool thing about Omdena is that they really value human interaction. So still we focus on this design concept called human-centered design. So that's really like a plus for me that I've learned. It's not really like there's a boss, there are leaders, there's no such thing as that. Even me, like when I approached there, like I really didn't know a lot, and there's so many things that I've learned with just 3 months.
That's really great, Brash.
Yeah, I guess Bash, like one question, which I think like our audience would be really interested in is like, is there like do you have team members that don't necessarily have a lot of years of experience? Like maybe let's say they only have like about a year working as a data scientist or something.
Yeah. One of the collaborators in my group is not really like they don't even know how to like code even like code really well, but they know some Python already. But really, no one is an expert in these types of jobs. So you really learn collaboratively. You don't need to know anything because you're there to learn. We never stop learning. So you can learn through the process. Don't be shy. You need to really be used to this intense culture of diversity. You need to really proactive in reaching out to people because at the end of the day, you want to maximize your experience not only for yourself but the way that you can really solve the problem to help other people.
Great, great. Thank you, Bash. Like, kailangan talaga self-starter, no? Very proactive. So, thank you very much, Bash, for your presentation and for sharing your insights on what you've learned with Omdena. So Rick, what a very insightful Saturday evening, no? Like, big thanks
Yeah.
again to Bash, Lucy, and the Omdena community for this exciting opportunity of collaboration with like-minded people all over the world. So Rick, there's so much to be excited about this evening, right? So I'm also excited about the results of the votes from our audience.
Right.
So are you guys ready to hear the audience favorite of today's demo day?
Yep, I can't wait, Thea. So let's announce it. Drum roll, please. Do we have drum rolls? Okay, probably not. So the top two project from your votes is building an e-commerce gift recommender system based on a user-generated wish list. So that's the group of Emmer, Ran, Dan, and Rob. So congratulations to you guys, Team Santa All. And finally, the top one project for this night is forecasting the power demand of the Luzon electrical grid using clustering and predictive modeling by Jaleel, Will, and Jonas. So congratulations, Team Power.
Congratulations, Team Santa All and Team Power. So it's been really a fun evening, and unfortunately, we're nearing the end of our program. But before we let you go, I'd like to call on Aurelian, our co founder, to share with us his closing remarks. So please take the virtual stage, Aurelian.
All right, thank you, Thea. I know boot camps have a way of kind of dilating time, so it wasn't actually that long ago that we started this, but it probably feels like it was very, very long time ago. So I want to congratulate again all of the fellows for having made it this far. I know it was an intense and blistering journey. That's how boot camps are, but I hope that you've learned a lot along the way, not just in terms of your data skills, but also about your own endurance and discipline that it takes to get through this, and that you're happy to have shortcutted material that often takes people semesters to learn into a few jam-packed months instead. You will always be able to look back on your time and think that in a time of a typhoon, a global pandemic, you used your time productively to learn one of the hardest skills that you can. And any future team is going to be lucky to have you, precisely because the tenacity, the teamwork, and the learning aptitude that you've shown here are the traits that will make you successful in your careers as data scientists. So at the same time, even though we call today the graduation, the demo day, this is actually only the end of the prologue for you in data science. Data science is one of the most exciting fields because it's always changing. There's always new things to learn, and you're never going to run out of new things to learn. So we are happy to give you your weekends back. You're probably quite happy about that too, but we also hope that you never stop adding new models, new libraries, and new projects to your repertoire. A data scientist's key personal metric to optimize for should always be your own rate of learning in a sustainable way. So Eskwelabs was started last year to accelerate the journey of talented and driven individuals into the world of AI and big data. And we chose to focus on data science because in many ways we see in this field some of the values that we believe in. This is a field where your curiosity, your love of learning, the skills that you develop are what make you successful. It's not who your parents are, where you were born, or even where you went to university. This is the skill set that's going to build the future. But it's also up to all of us as members of this community to make sure that that future reflects the values that we want to see in the world. And so now we request that you, now that you are alumni, you join, you find ways to give back to the community. And of course, you're always welcome to join our alum projects, the reunion party, and maybe come back in 2 years and teach a sprint of your own. And finally, for everyone else who's been watching this, if you could only have been at the beginning to see how far the fellows have come in such a short time, but if you're already thinking that you might want to create your own Santa recommendation engine or your own power forecast, or any other project you might have on your mind, we invite you to join the next cohort in January. So congratulations again to all the fellows. Welcome to the data science community, and a big invitation to everyone else to join us for the next cohort.
Thank you very much, Aurelian, for that inspiring message. So as we say goodbye, again, special thanks to our guest judges, Lorenzo and JC, guest speakers, Bash and Lucy, and to Mikey for the dropping performance. And of course, a big round of applause to our fellows, our main casts of this demo day, for their amazing projects and presentations.
So on behalf of Eskwelabs, thank you to our audience for staying tuned with us this evening. We hope to see you in our future events, and maybe you'll be the one on this side of the screen presenting your very own capstone project. So again, thank you for joining Eskwelabs Data Science Manila Cohort 5 Demo Day Innovating for the Recovery. Enjoy the rest of your evening.
Di alam kung ano meron ka na hinahanap-hanapin kita. Even if I try so hard to tell myself I don't like you. You're confusing, I need a loving, so conceited, but I like it. I can even hear a word you say, so stop and listen. Every time you la la la, makes my heart go la la la. I don't even na 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 know what you're doing, but you make me la la la. Every move I la la la. I don't even na 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 know what I'm feeling. Pag tinitingnan kita, everything's so perfect. Pag ngumingiti, good looking and I think you know it. Tawa kong pilit even though I don't know what's funny. Boy, I try so hard, don't even know if you like me. Do I like you? I don't think I do. Do I mean it? Maybe a little bit. I don't wanna think about what this really is. All I know is you and I'ma go into the great abyss.